Hello everyone, welcome to Lara Shah National Laboratory. Today we'll be conducting an experiment with a pendulum, trying to figure out how does the time of the swing change as I change the angle of the swing. So as you can tell by my very high-tech protractor, we've got multiple angles. We've got our string, we've got our pendulum down here. If you take a close look at this protractor, you can see that it is split up into equal sections that are 11.25 degrees each, meaning that when the weight is hanging straight down, it is hanging at 90 degrees. This protractor spans from 0 to 180 degrees. Before I begin, however, I have to acknowledge that I'm not a perfect robot. I am a human, and as such, I sometimes make slight errors. I'm going to do 3 trials of this pendulum to see what the error or the uncertainty is in my measurement. Sometimes I might hit my stopwatch a little bit too fast. Sometimes I might hit it too slow. So I want to take the average of 3 different trials to see roundabout how uncertain my results are. So I'm going to do, forgive me as I log on, I'm going to do 3 trials at 112.5 degrees. Okay. I'm going to time it as it goes back and forth, back and forth. So I'm going to get 2 full revolutions of the pendulum. I will do this 3 times and we'll see how long it takes. That took 3.49 seconds. This is my first data point, 3.49 seconds. I'm going to reset. We're going to try that again. I'm doing 112.5 degrees again because I want to see how fast or slow my trigger finger is. And I'm going to go 3, 2, 1, back and forth, back and forth. That time, it took me 3.16 seconds. So you can see that I'm not perfectly catching the pendulum at exactly the right time, which is why I'm doing this several times to see what the uncertainty of my measurement is. Third trial. 3, 2, 1. Forth, back, forth. And this last trial took 3.2 seconds. So here are the 3 trials, the times for the 3 trials that I did to figure out the uncertainty in my timing. The first thing I'm going to do is to figure out the range between my shortest time and my longest time. So my longest time was 3.49 seconds. My shortest time was 3.16 seconds. The range is the difference between those 2 times, which comes out to 0.33 seconds. My uncertainty is that range divided by 2. That gives me an uncertainty of 0.17 seconds. What this number means is that from now on, when I take a measurement, that measurement might be off by about 0.17 seconds. So even though I record a specific number, that specific number is not exactly the true value of that time measurement. It could be 0.17 seconds higher, it could be 0.17 seconds lower, just because I'm not exactly catching the stopwatch and the pendulum at the same time. Now we are going to test several different angles and see how long it takes for the pendulum to swing from those different starting angles. Before I do this, I want you to make a wild guess. What do you think is the relationship between the angles and the time it takes? When my angle is larger and larger and larger, do you think it's going to take longer for the pendulum to swing, or do you think it's going to take less time? So stop right now and please make a wild guess. I'm serious. You need to actually do this before I do the experiment. I'm not going to keep going unless you make the wild guess. Pause the video, make your hypothesis. Alrighty, let's get started. The first angle I'm going to test is 101.25 degrees. Some of you are asking, Michelle, why are you using such strange angles? And basically what I did was I took the 90 degrees, divided it in half, divided in half, and divided in half. So I get these weird quarter angles. It was just the easiest way to set up the protractor. Trust me, the math will work out. Now I'm going to time how long it takes for 2 revolutions when I drop the pendulum at 101.25 degrees. Ready to go. Alright, 101.25, 3, 2, 1. Okay. 101.25 degrees took exactly 3 seconds. My next angle is 112.5 degrees. The next angle is 112.5. Let's check it out. 3, 2, 1. At 112.5 degrees, it took 3.19 seconds for the pendulum to swing. The next angle I will be doing is 123.75 degrees. I'm going to be testing 123.75 degrees. 3, 2, 1, go. It's obvious it was already written. You can see it. At 123.75 degrees, it took 3.05 seconds for the pendulum to swing. I'll do one more angle. Let's go up to 135 degrees. I have to be super careful that it's aligned so that it doesn't hit. 3, 2, 1, go. At 135 degrees, it took 3.42 seconds. Please make sure you copy the stage table into Desmos, as this is the data we'll be using for the next section.